Hey, Matthias is here, your trusted advisor. Today we are talking about KQL databases. And first of all, there is, some confusion about what's a KQL database. The way I think about that is that I say, well, you have, let's draw it, right? You have like a building, like that. That's a building. That's the Eventhouse. Equals building. So this is my house. It's in the name. Then you have several KQL databases. The first one, which is not really helpful, has the same name than the building. The next ones KQL database. The next ones you can name as you like. So when you say, okay, this is the building, then the database is like the apartment. So it's part of the building. You cannot have a building without an apartment when you create the building. That's the idea. And inside of that database is the table. And the analogy to that would be, of course, this is like a room. So we have building, we have apartment, and we have room. In computer terms, you could say the house is the cluster. The database is obviously the database, and the table equals table in that cluster. Okay, so that's straight from the beginning. When do you need that? We talked about real-time several times. You need a KQL database to store data, streaming data, mostly real-time data, but streaming data. That's the purpose. Or KQL database. This is it, by the way. So we can create a new database by hitting the plus sign. That's very straightforward. You see, we have already two different databases here, the analytics database and the RTI demo database that we are ready to use. And we can create more databases like RTI demo database, for example. It's working on it, and so it's creating now the database on that backend cluster. Database is empty, and we can insert some sample data. In this case, we will do the weather data, and we see it here. These are weather events from more or less 20 years ago, with the state and some proper some metadata here, like storm summary, ingestion time, event narrative, and all that stuff. We can see the JSON, the detailed data, and we have the query set just right built into the database, where we can explore the data a little bit more in detail, which is pretty handy. It's weather data, and you can see we can simply pipe it to something like count, and then we will get the count. So, as I said, multiple databases share one cluster object. So let's have a look how the data is coming into a database. So of course, when we draw the target, it's like we have the database, KQL database, with multiple tables. So let's draw it in that case simple. Let's say these are the tables, right? And everything this is the database. This is a target, quite simple. But we have a lot of different sources. Let's go through the sources. Data, data sources. First of all, we have maybe the most prominent one, Eventstream. Eventstream means real time. When you bring that in the database, like that, it's like seconds latency. And it's streaming. Streaming is important because you have different techniques like tumbling windows and so on that you can apply on streaming data. When you have the source like local file or Azure storage, that's a one-time upload. Because you might need that for, you guess it, historical data. With that, you have minutes of latency. Next thing that you can bring in is a data pipeline. Data pipeline means a scheduled batch. Scheduled batch means, again, minutes of latency. Minutes. But it's an orchestrated batch. You have the very prominent one, Kafka. Or SDK or Telegraph. This is done by custom connector. When you bring this kind of data in, you have again seconds because it's streaming data. But it's programmatic because it's a custom connector. And last but not least, you have the famous, you guess it, OneLake shortcut. The OneLake shortcut is no copy because it's a shortcut. So when you bring that in, it's just the query time. The time the query needs because it's virtual. So these are the different ways how to bring data into a KQL database. Eventstream, which is the most prominent one. Local files for historical data, data pipeline for batch, Kafka, SDK Telegraph if you have an existing system, and OneLake shortcut, just to fool everybody. No, just kidding. When you need to bring in other data from OneLake. Oh, we are back on our KQL query set in the KQL database. Whether take 5 gives us a first 5 data as we can render bar charts. We will go a little bit more into detail when we talk about the KQL query set in a different video. But still, you see it's very handy to explore the data to get all that different bar charts, and we can create time series, right, with event count, start time, today time, render time chart. We can configure everything like titles and legends and X and Y axis and all that stuff. So it's quite cool. See it here. And we get everything in line. It's a little bit tiny here on that screen. For example, these are anomalies that we can see with event count and then baseline and anomalies just rendered in one very nice chart. We can switch back to the table and store see the total damage and the event count. So it's all in one place. It reminds a little bit to notebooks, in my opinion at least. So now we know which kind of data you can bring in, but there is this cache issue. Let's go through that. I've prepared the diagram because it's a lot of drawing to bring that down and writing, and I think it's easier when I can go through it. So we start with a KQL query, or we could also start with a database. In the end, we want to get data. And when we query that data, the first question is the data in the hot cache? When it's in the hot cache, this path, then it would mean that the local SSD really fast, and we have milliseconds response. When it's not in hot cache, we are on the OneLake standard storage. It's not slow, it's standard. Yeah? So we have packet files and we have seconds of response. We have database policies to define when is something located in the hot and when it's in the cold. So this is hot storage, this is cold. So to control the tiering. And here's the point. The default is long, 10 years. And this is really long. And you have to pay for that. So usually you want to bring that down to something that covers your usual amount of queried data. So often this is like something like 30 days. It might be 60 days. It might be enough with 7 days, but around that. And this is the caching policy. After the, as long as this is true, so let's say this is 30 days, as long as the 30 days are true, the data is sitting in the hot cache. After the 30 days, it will be moved to the standard or cold storage. The retention policy is something really different. It manages when the data will be deleted. There can be a valid reason for that, because it could happen that you store your data in Lakehouse. So you have the Eventhouse just for more or less hot storage, and you don't need the standard storage because you have that with the Lakehouse. Could be. So in that case, you would set that to the same value of the hot cache. When you want to hold the data longer but not forever in this case means 10 years, you'd say, okay, we will hold, I don't know, 3 months, 90 days of data in our database. It's up to you. Yeah? Either way, in the end, you will have a query result, but depending on the storage layer, after different amounts of time. So second part of our demonstration, we are still in the KQL database. You can see these are our KQL databases. In that cluster, we have the famous retention and caching policies that we can set here. Yeah, that was the wrong key. But anyway, you see the default is on the 20 on 10 years, and cache must be lower or equal to retention. Retention means delete, cache means fast. So this means after 1 year, when we enable it, we will delete the data. After 7 days, we will. It's time for our decision tree. I've put it here because, again, it's a lot of drawing, and I think it's more valuable that we talk about that. So the first question is like, what is your data source? Yeah. Is your data source streaming data? Is it transactional data? or is it historical data? So let's say it's streaming data. Next question is, how much volume? Yeah? More than 100K per second, then you will need a KQL database. Less than 100K, then you can go with a Lakehouse. When you have transactional data, orders, customers, and so on. Question is, do you need updates or deletes? If yes, you can go with KQL. If no, you can go with a SQL database or warehouse. Excuse me, wrong term. Do you need updates or deletes? If not, because KQL database is append only, you go with KQL database. If yes, you can go with anything that is writable, like SQL database, like warehouse, because both accept SQL. When you want to do something with Spark, you can even do a Lakehouse. Yeah. Last but not least, you have historical data like DB extracts, like files, and so on. Then the question is, who is analyzing? Yeah? When you want to have time series because of this windowing and so on, go with the KQL database. When you have a SQL team, everybody that loves SQL will go with the warehouse. So go with the warehouse or SQL endpoint on Lakehouse. When you have Spark or Python, you will go with Lakehouse because there you can build great stuff with Spark and Python. So that's the decision tree. So streaming event, transaction, historical data. For streaming events, it depends on the masses. For transactional data, it depends on update or delete or not. And for historical data, it depends on your favorite interface. So how does the data flow really look like? So on the left side, for sure, we have sources. But it's not just sources, it's event sources. We can have different things like, let's say, an IoT hub or Kafka or something else. This data is all going to real-time intelligence. And the first step in real-time intelligence is always our event stream. The event stream can do transformations, and it can route the data through different derived streams. From there on, within seconds of latency, it goes to the KQL database. The KQL database gives us tables and functions. The KQL database is part of the Eventhouse. From there, you have basically two different ways. You have multiple ways, but just one very simple and one complicated. Let's start with the more complicated. The more complicated means first you query the data with the KQL query set. Then you might publish the data to a real-time dashboard. And then you add a data activator, so you can raise alerts. That's like the complicated path, or more complicated. The simple path is very long and ends in a Power BI dashboard. Very simple, right? So you could say, okay, this is like the consumer part. So this is the overview. On the left side, we have event sources. Then we go in the RTI space, do all this data wrangling and so on, and end up on the consumer side. That's like, well, the overview, and it's like the closing part for the architecture part. And next we will go then to the community questions. Community questions. The top one: can I use SQL instead of KQL? I don't want to learn another new language. We are a SQL shop. Everyone knows T-SQL. Do we really have to learn KQL to use Eventhouse and the KQL database? The honest answer is yes and no. KQL databases support a subset, read-only subset of T-SQL basics. Select and where and group by and orders and joins, these work. So your team is not completely lost. You cannot do with T-SQL in a KQL database because there are no commands in T-SQL for that, like make series, like series decompose, like render time chart, and so on. So that's the point. You might want to use functionality that is not available in T-SQL. The good news, KQL is not really hard. It's a pipe syntax, it's readable, it's logic, so it takes about a day or something like that. And with modern AI tools, you might even not really need to learn everything. So yes, in the end, you will most probably want to learn KQL. How do I connect Power BI to a KQL database? I can write KQL queries and I see the results in Fabric, but how do I get that data in a Power BI report? 3 ways. So first way is a real-time dashboard. It's for live data. It's powered by KQL queries. You don't need Power BI desktop. It's really easy when you need the focus is on the real-time part. You can use Power BI with direct query. So get data, Eventhouse, and then use direct query. You could use import mode in Power BI, but of course this to some degree makes the streaming part a little bit of useless, because you have a snapshot then in the Power BI report stored. So you don't get any new data. So next question, what's the difference between caching policy and retention policy? I always mix that stuff up. Retention policy means how long does the data exist. It's default 10 years. When exceeded, the data is deleted automatically. So when you set it to 30 days, after 30 days, your data is permanently gone. Caching policy means how much data lives in the fast local SSD cache. Default also 10 years. Not the best choice. When we might set it to 7 days or 30 days or something that covers most of your queries. When your data is outside of that caching window but still in the retention period, it's a little bit slower. That's it. Yeah. So don't mix that up. Take care about the retention policy, especially because you cannot fix that when you make it wrong. How does KQL Database Explorer to Azure Data Explorer? Should I migrate? I'm still on Azure Data Explorer. Should I move? Yeah. So KQL Database is like the next evolution. Same cluster engine, same KQL syntax, but there are differences. So the deployment is inside Fabric Workspace. Before you needed a standalone cluster. The compute model is built by capacity points, by SKUs. Fabric integration is integrated in the KQL database, obviously. You have a built-in OneLake automatic mirror. You could do that with an ADX continuous job, but hey, it's built in then. And you pay it through Fabric, so a lot of advantages. If you are all in Fabric, the advice is yes, migrate. If you don't use Fabric at all, there is no need at the moment for you to migrate. Can I use KQL against Lakehouse or warehouse data? I have data in a Lakehouse and also in the KQL database. Can I write one KQL query that joins both of them? Yes, yes. That's why you have OneLake shortcuts. So you simply shortcut your data from the Lakehouse to the KQL database, and then you can join with KQL your data and your real-time telemetry data or IoT data or whatever together. Scenario 2 would be query your KQL database from a notebook. That will also work. My KQL database is slow after the Eventhouse works up from idle time. Yes, it's 2 hour idle time. Our Eventhouse goes idle overnight. Yes, this is the cold start problem. It has a direct solution. So why does it happen at all? When an Eventhouse is not queried for about 2 hours, then Fabric suspends this Eventhouse to save compute resources. When the first query arrives in the morning, everything has to wake up, which can take a few seconds up to maximum a minute. Solutions, you can enable the capacity planner, then your Eventhouse stays active 24/7, no cold starts, and the cache storage is included in your CU costs. It's not built separately. You can schedule a minimum capacity with the capacity planner and can save costs overnight, and you can adjust the caching policy. So when your dashboard, for example, always says last 7 days, then cache your last 7 days, obviously. Some pro tips from the community. First of all, use the sample data. Sample data is great for learning. You have seen that in our demonstration. Use it. You will learn a lot of stuff. Tip 2 is use bin for all time series aggregation. So bin timestamp 1 hour is your best friend. It rounds timestamp to the nearest hour boundary. Without it, every millisecond has its different group, and your time chart look like noise. Match caching policy to your query window. We already talked about that. Render is only for a KQL query set. That's a great one, not for production queries. Also, render time chart is a visual operator. You should use this to see the data, but it's not an operational query because it's ignored, right? Use take, not limit, for quick data checks. So in KQL, you have take 10 and limit 10, both work, but take is idiomatic and signals to other KQL readers that you want a quick sample, not the deterministic top 10. So the first one is just a sample, take just 10. The second one means I want exactly the first 10. So take 10 is faster. That's from my side about KQL databases. I hope you enjoyed it. If you want to get a notify once I release a new video, just hit subscribe on the YouTube channel, and hope to see you next time. Take care.